You've probably heard about prime numbers before. Today in this video we will discover the prime numbers between 1 and 100. Is 2 a prime number? What about 11? How about 31? Let's look at the numbers from 1 to 100 to find the prime numbers. First, let's review what a prime number is. A prime number is a number that has only two factors, those being 1 and itself. So let's list some factors of some numbers and see what we find. Let's look at the number 1. What are the factors of the number 1? Well, the only way I can get 1 by multiplying two numbers together is 1 times 1. And so the only factor of 1 is 1. Because that's only one factor, the number 1 is not a prime. Let's look at the number 2. How many factors does the number 2 have? Well, the only way we can get 2 through multiplication is 1 times 2. So the factors of 2 are 1 and 2. And since this is two factors, 1 in itself, this is a prime number. Let's try the number 3. How do you get 3 through multiplication? 1 times 3 is 3. So the factors of 3 are 1 and 3. And again, this is two factors, 1 in itself, and that makes the number 3 a prime. Let's go to number 4. How can we get 4 through multiplication? We know 1 times 4 is 4, but we also know 2 times 2 is 4. And so the factors of 4 are 1, 2, and 4. And we can already see that is 3 factors, not 2. So that makes the number 4 a composite number and not a prime. Let's look at the number 5. How can we get 5 through multiplication? 1 times 5 is 5. And so the factors of 5 are 1 and 5. And again, we see that this is 1 in itself, two factors, which makes the number 5 a prime. How about 6? The factors of 6, we can multiply 1 by 6 to get 6, but we can also multiply 2 by 3 to get 6, which means the factors of 6 are 1, 2, 3, and 6. That makes 4 factors, which makes 6 not a prime, but a composite number. Finally, let's look at 7. 1 times 7 is 7, and so therefore there are only two factors, 1 and itself, which makes 7 a prime. Notice something about the numbers 2, 4, and 6. The number 2 has factors of 1 and 2. The number 4 has factors of 1, 2, and 4. The number 6 has factors of 1, 2, 3, and 6. And if you notice, these are even numbers, 2, 4, and 6. And each one of them has factors of 1 and 2. Therefore, the number 2, 4, and 6 can all be divided by 1, and they can also be all divided by 2. And so as a reminder, the number 2 has factors of 1 and 2. And looking at 2, 4, and 6, we can see that each one of those even numbers also have factors of 1 and 2 and some other numbers. So what does this tell us? This means that each even number as high as we can count will always be able to be divided by 2. And therefore, every even number greater than 2 has a factor of 2 and can be divided by 2 along with 1 and itself. And so you will never get an even number greater than 2 that has only 2 factors, because 2 will always be a factor of every even number greater than 2. So every even number greater than 2 will always have 2 as a factor, and that results in the fact that 2 is the only even prime number. This is very important to remember. 2 is also the first prime number, and it's also the only even prime number. Every other prime number higher than 2 will always be odd. Let's discover the prime numbers by using the 100 number grid. To find the prime numbers using the 100 grid, we are going to step by step start to identify the primes that we know and then get rid of all of the other numbers that can be divided by that number. So let's go. Step 1. 1 is not a prime. Let's eliminate it. Step 2. 2 is a prime. So we're going to keep that. But we're going to eliminate all of the multiples of 2, because every multiple of 2 greater than 2 can be divided by 2 and therefore has 2 as a factor. So it cannot be a prime. So let's get rid of all of the multiples of 2. Wow, that was a lot of numbers that disappeared. Step 3. 3 is a prime, so we will leave that, and then we will eliminate all of the multiples of 3, because every multiple of 3 after 3 can also be divided by 3 and therefore has 3 as a factor. So it will always have more than 2 factors at that point. So let's get rid of all of the multiples of 3 that are left on the board. I see 9, 15, 21, and all of the other multiples of 3 we will get rid of. And now we're getting closer and closer to the prime numbers between 1 and 100. Step 4, 5 is a prime. So we will leave 5 and then eliminate every multiple of 5 after 5. And now step 5, 7 is a prime. So we will leave that and get rid of every multiple of 7 after 7. And I see 49 and 77. We will eliminate those. And now what's left? Between 1 and 100, we have eliminated a lot of numbers that had more than 2 factors. These are the prime numbers. There are 26 prime numbers from 1 to 100. And now it's quiz time. Is this number a prime? See if you can remember. 41. Yes, 41 is a prime. We will recall our prime numbers, and there is 41. Number 2. Is this number a prime? 27. No, it isn't a prime. Even though it is an odd number, 27 is not in our list of prime numbers, and we know that 27 can be divided by 1, 3, 9, and 27. So it has 4 factors and not 2. There are more than 2 factors, making this a composite number, not a prime. Number 3, 19. Yes, 19 is a prime. We check back with our list of numbers. 19 is in the list of prime numbers. And question 4, 38, is that a prime? The answer is no. 38 is not in our list of primes. We know 38 is an even number because it ends in 8, and therefore it cannot be a prime. It can be divided by 1, 2, 19, and 38, which is 4 factors, which means it is not a prime. And now you've solved the mystery of how to find prime numbers. Well done.